Hi, everyone, and welcome to the HCBiz Show, episode 32. This is the weekly show where we take on the issues and opportunities facing the business of healthcare, and we come at it from a very practical standpoint. Our goal here is to find out what are the issues, why do they exist, and why haven't they been solved and or taken advantage of yet in the market. And our goal here is to send you away with some very actionable info, things that you can start to use right away. So this past week, my co-host Shahid Shah was able to attend the IBM World of Watson conference in Las Vegas. And he was really impressed with what he saw, both in production value from the show. IBM puts on a great show, but also in the quality of the content and the demos and the examples of people who are taking advantage of the IBM Watson platform in production in healthcare today and how they're impacting their businesses. So we decided to dive into this for this week's show and talk about the whole gamut of it. What is IBM Watson? What is machine learning? And what does all this stuff mean to the future of healthcare? And we get into a lot of really interesting aspects of this, starting out with basically painting the picture of the state of analytics today and how the machine learning and cognitive computing are causing a fundamental shift in our approach to knowledge gathering and really knowledge creation. So after that, we're going to talk a little bit about the issues that are going to come up around sharing of expertise and knowledge and the intellectual property rights and things like that that are naturally going to come up in a free market like we have. And we're also going to touch on some of the medical ethics issues that are going to come up. So beyond that, we're going to talk who has opportunity in IBM Watson. And we all read the headlines, and it seems like this is something for the big guys. It's really not just for them. Yes, there are opportunities for large academic medical centers and for large cancer institutions, but there are APIs available right now if you're a startup that you can grab, and you can really have something up and running in a matter of hours with little to no upfront investment. So there's a lot of opportunity here for everybody to start getting involved, start learning from all of this stuff. We're going to drill into some of the advances in imaging and video processing that these capabilities allow us to do, and what that might mean for areas of medicine like radiology. Finally, we break this down and talk a little bit about how these systems learn. So none of this is magic. It is really about learning systems and how do we train them. So we break down how do we create these sustainable and scalable feedback loops that will allow these systems to process the massive amounts of data that they can use and impart some of the expertise from the experts in the field today. So with that, we did have a little bit of a problem with our feed. For the first 10 or 15 minutes, latency quality was really low. So I've chopped that, and I'm just going to give you a quick summary of what Shahid and I talked about to set this up, and then I'll drop you in the conversation. The rest of the way is nice and smooth. So where we started was the state of analytics. Originally, analytics was basically reporting. As you had programmers and you had data scientists who had access to data and who had abilities to do something with it. So they would take it, they would apply rules to it, they would produce some output, and they would give this static output to the quote unquote business side so that they could use it to make decisions, be it business or clinical decisions. But it was really the static thing that the consumer couldn't do a lot with. So the next logical step, we started to see business intelligence tools that would allow not necessarily programmers and not data scientists, but folks who could pull in multiple data sources, build their own reports, interact with them, create dashboards, et cetera. Really started to democratize the data and reporting. After that, we started to see predictive analytics. And that is the exercise of taking data that you have and applying rules to it in a way that we can use it to predict, based on what happened in the past, what might happen next. And that's kind of where we get to when we start talking about machine learning. That's the next step in this evolution. And really the fundamental shift is this. All of those first three aspects that we talked about, they're all algorithm based. So basically take an input, run it through some process, set of rules that we've created, you produce an output. the humans have programmed those rules and they've programmed that algorithm. With machine learning, the humans are creating and programming the learning system and they're training it, but they are not telling it exactly what those rules need to be. We're giving it guidance and we're giving it boundaries, but we are letting it, based on our training and the data that we've given it, start to create those algorithms for us. That's the big difference. That is what machine learning means. So all of this kind of sounds like science fiction, but based on what we saw at IBM World of Watson and what we're seeing out in the field right now with cancer research and diagnosis and everything else, this stuff really is starting to happen. So the trajectory of it is way up, especially over the last couple of years. We've made a lot of progress, but we got to be realistic too, is that we are 5-10 plus years away where we can even begin to think about meaningfully replacing the things that the expert humans can do today. Obviously in healthcare, that's a big question, is IBM Watson trying to replace doctors? And the answer is no, not today, not at all. The goal is to aid those doctors, to aid the experts by being an extra tool in their toolbox. And really, IBM Watson's strength and the strength of cognitive computing and machine learning in general is that they can consume this massive amounts of data. They can do it quickly and they can do it as soon as it's available. Just based on a doctor going to the office every day, taking care of patients, keeping up with the literature and the studies and everything else. It's not reasonable to think that any individual human could keep up with every medical study that comes out and every new medication and understand all the side effects and everything else. And it is theoretically possible for that to happen in a system like IBM Watson. So you put these two things together. You take that just consistent mass data processing, consistent rule application that IBM Watson can do, and you match that with a really powerful diagnostic team at, say, a cancer research center, and now you've got a really powerful team. And that is the state of machine learning today, is that human machine team and how they can work together basically to give us the best possible outcomes that we're capable of today. So this gets us right to the point where I'm going to be able to drop you in the video. The topic that we're discussing when we get in there is really around, I asked Shahid, is IBM creating this central knowledge? Let's stick with cancer and say, is it creating the central knowledge of expertise and know-how around cancer that is being shared in by these various academic medical centers and cancer institutions that are using it? And as you'll see, that's not quite the case. And Shahid will explain why, and it really has to do with the expertise in an area at one center is an advantage for them. And it is not something that people are just going to freely give away. So that's going to get us into the IP conversation, the medical ethics conversation, and a whole bunch of other interesting things. So thank you for joining us. I'll drop you in the video now. I hope you enjoy it.
Intellectual property, I'm pouring this in there, you cannot get results. So there's going to be a lot of confusion here, because there's going to be the idea, oh, Watson now knows this at Sloan, therefore Watson must know it at UCLA. And that's not true at all, because we're back to the same interoperability problems that we've talked about many times. So again, you got the engine, you started pouring some data into it. As you're starting to pour data, you now have to prepare lexicon, like what is a dictionary? So for example, in medicine, the same term can have multiple meanings. So you have to start applying lexicons to specific articles, to keywords. There are ontologies created for relationship mapping. There are dictionaries available so that when a question is asked, like if I ask the question, as natural language processing is done, it has to go check the ontologies and the lexicon to then point me to places. So as you can see, at this stage, it's still early days, and the value you get out of it is really good, but it's not trivial. You can't just buy Watson off the shelf at Walmart to install it on your machine and then say, okay, let's go work on my cancer or my diagnoses at this point. So still a lot of work because of the knowledge part of this. And so you almost have to, you've heard a little bit about Watson having to go to school. That's literally what it's doing. It just can go, it can get a 4-year degree in a week, whereas it takes us literally 4 years to go through that process. So lots of learning still necessary.
Very good. And that's exactly what I was hoping to get into. So you broke that down. Great. So IBM Watson is, they're perfecting the learning engine, and they're perfecting the infrastructure that allows this stuff to happen. But as you said, there's not like this central growing knowledge base of cancer treatment, for example. Unfortunately, right, we're going to end up with these same kind of competitive and interop type issues that we see in other places in healthcare. Is there any groundwork being laid for sharing in this knowledge? Because there's going to be, like, let's say the basic set of cancer treatments, or the basic knowledge, the things that are pretty much best practice across the industry. But again, so there wouldn't be necessarily a competitive advantage from one site to the next. But again, having the ability to have an intelligence augmentation, as you said, is there any groundwork being laid to share in at least that basic level information, so that we can have very consistent treatment of certain types of cancer, for example?
I think IBM would love to do that, but one of the points that Jeannie, their CEO, made in her keynote at the end of the conference was they want to not get in the middle of any intellectual property confusion, disputes, conflicts, however you want to say it. I mean, she was very diplomatic about it, but you and I know that these things, I mean, the fact that Sloan is better at certain things gives them competitive advantage. That doesn't mean that they're going to want to withhold that information generally, but they're going to want to say, okay, they spent a lot of money building that knowledge, and they're going to want to monetize that in some way. And I welcome that. And I think that nothing about deep learning prevents us from doing the sharing. And so when you think about it, multi-tenancy has to be built in. Data lineage, and I had a lot of conversations with folks at IBM about data lineage, meaning the idea of provenance, attribution, lineage, knowing where did that information come from. So for example, if you had a shared knowledge base, and it turned out, Don, you had done a bunch of research, and we could trace that the answer provided for a particular question came from the research that you did, then you deserve some level of monetization, citation, references. For example, if you wrote a blog post today and got that knowledge from me, you would link to me, and that gives me a little bit of extended credibility through that reference, and it gives you extended credibility because you cited me. So that kind of thing, we still don't know exactly how that's going to work. How does lineage go, and how do we know that the sources of information are properly going to be accounted for? So this is why when you're working within an organization, it's their stuff, right? So, they've already bought this content, they bought the knowledge, that content and knowledge has been paid for, it's now been loaded. So life becomes easier when it's a single tenant managed in a particular institution. But as you grow, think about the 2 or 3 major problems. One is, how do you load that knowledge, which we just talked about? The second thing is, how do you track it and trace it through lineage and provenance and attribution? But thirdly, is the ethics. How can you use, if you go back to the ethics around what the Nazis were doing back during World War II, basically doing experiments on Holocaust victims, etc. That knowledge that was gained, everybody in medicine knows that you can't use that ethically in the same way that we would use through a regular clinical trial that we would do that is fully approved, etc. So the ethics of what, and I'm not saying that Watson needs to know about the Nazi part, but that was an example of medical ethics, which is clear cut. Medical ethics as associated with how we're going to use this data through deep learning, linkages that could have never been made by human beings are going to be made by Watson and other cognitive systems. So the ethics around that are still very young. The idea that we have to understand where all this data comes from, how we're going to use it, that's still there. So I think it's easy as far as the technology is concerned. We can create one giant instance at any facility we want. We can do kind of like what the government did about 7 or 8 years ago when they bought SNOMED and CPT codes and ICD codes for everybody. They bought them, put it into the NIH National Library of Medicine, And now anybody can use that as part of the usage for meaningful use or anything else, but they still pay the knowledge owners. They just pay them one time for the entire nation's use instead of that knowledge owner selling it one at a time. So I think those kind of things are going to happen in order to help us in this sharing model. But we are still years away before we can figure that out.
That's great. And, maybe that's something in terms of the cancer moonshot, obviously high government level support for that. Maybe that's something that they might look into over time, is how do we free this data up so that it is available, while making sure that, the creators of the content and of the knowledge do get compensation for it. So, and I agree with you 100% there too, is that aspect of it needs to happen. That's what drives a lot of this work. And we need to keep that alive to foster that. So in terms of our typical kind of HCBiz approach to things, we want to talk about what's actionable right now. So obviously IBM Watson, very young, very exciting, but not super actionable for a lot of people. Who is it actionable for right now? Who, obviously the Sloan Ketterings and the major cancer hospitals and huge systems should be considering this stuff and looking into it. But who has an opportunity here?
So I think that almost all of us should be looking at anyone doing analytics of any sort. And so today, the most kind of analytics that we need is multi-stakeholder, multi-institution analytics, where anything that's being done in a collaborative way across multiple institutions, we're pulling this data together for value-based care, evidence-driven care, those kind of things. When you pull that data together, if it turns out that you have enough data scientists, enough data analysts, and folks available, and your analytics is doing really well, you're able to solve all your patient problems whenever you need them. You have answers to questions whenever you need them. If you're able to run the analytics and get your finances done, your reporting done, you don't need any of this. I mean, your business is working fine. But if you're an academic medical center and you're dealing with tough cases, and the only way to be able to resolve or cure those cases or treat those cases is through knowledge that it doesn't matter how many smart people you have, there's just not enough human beings to do the research you need. You need to be looking at this kind of stuff. So I would say academic medical centers that are not looking at deep learning, machine learning, cognitive computing are doing themselves a disservice. As you move down from, and I shouldn't say down, but let's say to the side from academic medical centers, where academic medical centers typically deal with the most difficult cases with the least amount of routine, that's where those cases go. But then you have a lot of routine cases at a normal health system. Let's say, whether it's a rural health system or an urban or suburban health system, you're looking at a lot of routine cases. You should be applying machine learning and basic kind of deep learning capabilities to tell you whether or not your routine processes can be improved. So there's a lot of cases that could be sent in and reviewed. So there's audit committees that review cases and medical cases and how you diagnosed and treated. Those should be sent in for automated review, so that you're not doing a statistical review of 1 out of every 100, but instead you could review all of them at a particular level. So I don't think there's anybody that's at the medium to large health system, or certainly at the academic health system, that should not be looking at cognitive in general, machine learning and deep learning more specifically, because there's a lot of value in it. In the same way that nobody would not be looking at analytics or reporting, et cetera, already, this is an area they should be focused on. The one thing to remember, though, is that the systems like Watson and any other cognitive toolkits have voracious appetites for data. So if your data is not well structured, you don't have lexicons, et cetera, start working on data governance, which will pay you spades back in an ROI anyway. So as you start to work that angle, then you can start to say, okay, let's apply some of these machine learning and other techniques. Machine learning and deep learning in Watson will be the same in a couple of years as today we have for reporting systems, right? So it's one of those things where you just need to be ready for it before it arrives, because it's going to be a massive competitive advantage to anyone who has it. I tweeted out a few times while I was there is, I feel sorry for anyone who's not going to understand machine learning and cognitive learning over the next few years, because the pace for any company that has good data that is reasonably structured for it to be poured into a machine learning system is going to be so fast, because these systems they learn at faster than human scale. And if they learn faster than human scale, and their competitor next to them doesn't have these systems, you can just imagine how much better they're going to be. So it's going to be a competitive problem for a lot of companies that are not starting with it today.
How about in the payer space? That seems like, based on the description you just gave, that seems like a good market for this in terms of tons of data, especially in the large national payers. Tons of data coming in, tons of processes and workflows to be analyzed. Is there anything happening over there?
So the payers haven't really picked up on this yet, because I mean, in the payer space, the idea is that, you know, claims are pretty easy. All they do is claims processing. So that's I'm giving you a broad overgeneralization, which is always a bad idea, but that's where they are today. Now, some payers, I can't name them, but there are some payers at the very large end that are looking at machine learning to find and discover patterns around fraud, improper prescribing of controlled substances, these very specific areas where, again, lots of data, patterns that humans can't just see and that machines can identify better. So they're doing with fraud and things like that what the health systems are doing to find, you know, bioinformatics and genetic space kinds of things. So there are experiments going on, but probably not as fast as they need to be. My thing is that, you know, if you have 2 or 3 projects that you're working on, say, you know, one is a standard analytics project and one is a machine learning project, it turns out there are 2 kinds of data. One is explicit data, which we know how to deal with very well. So if I can define it, I can understand it, I can report on it, I can collect it, that's explicit data. Implicit data, of which there is far more. Explicit data is like a tiny, if you think about an iceberg, the iceberg at the top is the explicit data, and then there's a giant chunk of data underneath, which is implicit. Implicit are all those things that you and I haven't been able to identify, or as data scientists, we don't know how to classify, categorize, but they're there. The relationships, if a machine were taught enough, could connect the dots. That's the piece we should look at. So if you're a CIO, if you're you're a CTO, you're heading up a data science effort, you strategically need to say to yourself, should I focus my effort on explicit data, or should I say, okay, let's remove 25% of the budget and time allocated to explicit data and move it to this implicit side? Because what's really nice is, if you can get the explicit side working even marginally well, it will move so much faster through regular machine learning than your explicit side will, that you may not need to do any explicit ones anymore. I mean, imagine if you were able to have data which could be restructured through better and better technology over the next few years, and you never had to do a schema design again. You just poured data, taught it how to do things, made the connections, did the lexicon and the analytics and the ontologies, and then the machine did the reorganization, reclassification, discovery, analysis. This sounds like science fiction, but it's not. This stuff is here today. It works today. You use it with these small applications like Google Search and Yahoo Directory. I mean, they exist. You know, we talk about the best example of machine learning is when your face is recognized, like face detection. You know, those squares in cameras, that's called face detection. And if you can, there's a reason why we know how to detect faces, because the machines have learned. Nobody taught it how to do that, but it learned what faces look like. We know, like if you do a Google image search today and say, okay, find me all pictures with a rhinoceros in there. Well, it's not like Google went out and found everything and labeled it rhinoceros with a keyword. I mean, that was the old days of doing things. Now you teach it what a rhinoceros looks like in 100 pictures, and then the machine goes into all million pictures and finds anything that looks and acts like a rhinoceros in those. And this is happening in video analytics as well. IBM showed some very cool examples about how once that you can teach them what a human looks like in a picture, you can actually track humans in videos. So we talked about a number of different techniques of using that in hospitals. So this stuff is here, it's real. That's the one thing I learned over last week, is that even a year ago, a lot of this was talk. And you know, I made fun of it just like anybody else did. But as an engineer, I was looking to those areas where there's something tangible, real. Can I touch it? Can I feel it? Can I get an answer if I ask a question? And on the show floor, demos galore, right? There was no shortage of seeing something working, how repeatable it was, how reusable it is, how much at scale, how much of it was in production. Those are things to worry about, but I think they'll go pretty fast over the next few years.
Got it. And on the imaging side, and I think it was Google that did this, a pretty interesting example was they were demoing examining images and asking the system, is it huggable? So they would show a picture of a teddy bear or a kid or like a block of ice, and the machine was saying it's huggable, huggable, not huggable. And the really interesting example was that they showed it a picture of a cloud, and a cloud looks fluffy and soft, and it's from all of the aspects that you would think about it, you might guess that the computer would get tripped up on that and say, yeah, the cloud looks huggable, but it identified it that was not something that you could physically hug, and that is not huggable. So same kind of thing as like training over time with all these images and letting it learn, and able to decipher those very fine details, to make that difference. So
right.
Really cool stuff.
That's a good example of how that was done, though. So as the business of healthcare folks, so the one thing that Google has going for it that IBM would be struggling with is being able to do learning and training at scale. So the way that they did that is there was a much smaller, so there was that same image corpus was used, and then they used the crowd to say, is this one huggable or not? So as you and I say yes and no, that's not just a cool system that we're using. We're actually training it at the same time. So there were hundreds, if not thousands, of people that looked at a cloud and said no. And now Google knows that, DeepMind, which is Google's AI system, knows that the cloud was not huggable, not because it learned that on its own, but together with its ability to see the images and see that this was a cloud. And then enough people saying no, 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 it has now a statistical correlation that cloud plus huggable equals no, not cloud plus huggable equals yes. Now, in the old days, we would have said that we would have to train that with an expert system, like 3 cloud experts from the world would have gotten together and spent weeks training it to say, okay, this is cloud, 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 not huggable, not huggable, not huggable, right? Using systems like Prolog and other expert systems. But now think of it, Google has literally enormous scale. It could actually present this and we could do instant training. You can train in 3 days what would have taken us many, many years. So Google and Microsoft, because they have consumer front ends, have a little bit easier job there. Now, in the case of IBM, because Watson is being poured in, that's the kind of training that it will need to do with enough patients and providers that are clicking these yeses and nos. So the training and the algorithms, and I'm glad you brought that up because it's still not magic in that way, right? Somebody's saying yes to this and no to that, even after all of the corpus has been kind of like poured in to the engine at the beginning. That training is still something that has to be worked on, though.
Gotcha. That's great. And that feedback loop then, that kind of pushes the use case, at least the more accessible use cases, towards that thing that you can have more people give feedback on. So as you start to get into the more complex things, obviously like very complex cancer cases, your audience of potential feedback givers gets much smaller. It's down to just those experts who can do those things. And one of the examples I was thinking about just before that, and I'm curious what you think in this context, is on the security front, analyzing internet traffic and analyzing typical patterns and looking for anomalies, and how that might be able to build an intelligence where IBM Watson could play in that space. How difficult would it be to have a feedback mechanism to start to identify those types of things? Because now on the internet, just the traffic and the volume of requests and data packets flying all over the place, not a real easy thing to quantify. But we do have red teams sitting out there who are regularly watching this traffic and doing just that. So what would be a model where we could take those security experts and utilize them to train a Watson platform or an AI platform to maybe detect something coming, like the big outage that we saw on the East Coast last week?
Yeah, I think it's not only a necessity, but it's an imperative. I mean, we have to let it do it because humans can't work at this scale. So IBM did. I was at a couple of sessions where they talked about this particular use case of the breach from last week, the IoT breach that we're talking about, and they did talk about Watson's ability, because it's a learning at scale system. So I mean, it can be applied to a variety of these things. But so if you think about where cybersecurity is today, not everybody runs a SIEM, an SIEM, a security information and event monitoring system. But SIEMs have always been thought of as log management tools. So you pour all your logs, they come into one place, and then you can do searches across there to find things, and then you find activities and patterns. But if you took a SIEM today and applied anomaly detection, behavior detection, change detection, then what you'd be able to see is, so one way to find out things like this, and machine learning is really good at this, is here's what normal looks like. If it doesn't look like this, everything else is abnormal. So once you start to see abnormal, this is how, the dying.com guy saw this stuff, right? Here's what normal looks like. And then all of a sudden a bunch of alerts go off. And instead of alerts going off, what machine learning could tell you is, here's normal, here are these anomalies now, which means that there's some change going on. I mean, it could be because the Super Bowl has started and there's a bunch of changes, so one would know that. But in a normal scenario, you should not see significant deltas. Your standard deviation shouldn't be that high. In those cases, if inside our SIEMs, we started plugging in the ability to do true anomaly detection, and there are nice learning patterns that could find those anomaly detections, variation detectors, then those variation detections would then get piped in, and the alert would say, we're seeing a 10% variation in bandwidth utilization from these 20 IP addresses that normally don't give us this kind. Now you've got, that's really smart, right? So if your SIEM had that capability, and this is what the guys at IBM World of Watson were talking about, is they have these capabilities to start looking at anomaly detection, but then so do others. I think there are a lot of places where I think any SIEM vendor over the next few years that doesn't build this in is just crazy. There's just too much data, like you were saying, for humans to be able to do anything with consistently. And that was your key point, is it's not so much that we don't know how to do it. I mean, we're pretty smart. We just don't, we might have a bad day and we might miss things, and that's where the computers don't miss things. But in the cybersecurity use case, it's a slam dunk. We can use it today for a significant improvement tomorrow morning, and then they just get better and better over time once you've taught them how to learn those anomalies.
Gotcha. And that's a really good way to look at it then too, is you don't have to have that feedback loop actively working on every single piece of data that's going on. You can really narrow the set of things that you want to evaluate by doing that. Here's normal, here's not normal, kick out the not normal. And now that's what you put in front of those experts for that feedback. And your Super Bowl example, they say, well, no, this is no big deal. The Super Bowl's happening, and that's a piece of feedback into the system, so that that type of pattern maybe next time doesn't raise quite the same alarm. So very cool stuff. I'd like to now is jump into a little bit of the specific use cases that you did see examples of, real working examples of at the World of Watson show. And I guess, let's talk about the ones that are use cases that are happening in the in the real world first, if you will, in production, where they're actually impacting decisions being made in business. And then maybe kind of talk about some, I'm sure you came across some of the more theoretical ones, the ones that are more experimental and maybe aren't necessarily impacting day-to-day business, but are likely to in some way in the coming 1 to 3 years, if you will.
Sure. Yeah. One of the neatest ones that I saw, especially because I spend a lot of time in medical devices, was at the Children's Hospital of Philadelphia, which is referred to as CHOP, C-H-O-P. That's not an insult. That's actually what they're called. So CHOP, in this case, showed how they were using streaming data in their children's hospital coming from a variety of different medical devices, pulling that into a in this case, it was a simplistic machine learning system. It wasn't Watson directly, but their future is to take this process that I'm about to talk about and then pour it into Watson, which is what they'll be working on over the next couple of years. But what they started to do was, as this data was coming in, they needed to find out real time. So there's a kid on a surgery bed being treated at a particular point. There are many questions that come up during that time where the doctor is working and the nurse is working, can't see the data fast enough as it might look, a minute or 2 minutes or 3 minutes down the line. And so they were working on self-generating algorithms. So they're first creating their own algorithms, and then they want us to do self-generating algorithms to look at where surgeries didn't go well in the past. And now, based on data which said, okay, if data looks like this right now at this minute, 3 minutes from now, some crash is going to happen, something bad will happen. And so they were using past data with current data, driving the algorithm to give an immediate response while an event like a surgery or something was going on. That I thought, if you look at the fundamental flaws that we have right now that prevent that from happening is most medical devices, even those that are digitally capturing sensors, not just analog to digital converters, but are capturing this and summarizing it, they have no way of beaming this data out in a reasonable way with proper telemetry data, timing, synchronization. So if we had, so what these will show is a place like CHOP could say, look, here's what I can use if you would just give me the proper data. Like it was almost a shame and almost criminal that these poor guys who are working to save children's lives were spending 80% of their time trying to get their data out of these systems, right? Out of the medical devices, combine them, collect them. But once they got it into the machine learning portions, then the algorithms that were being generated were very slick. I mean, they were able to show that if they could get the data out, there are some very specific, and they didn't want to share what all the specifics were, but they were able to do this using existing technology working right now. And so there are a lot of non-healthcare use cases, right? Robots walking back and forth and answering questions. They had a number of places where chatbots, it's called Watson Conversations, and there are a number of other companies that have similar capabilities. But I thought Watson's was very nice because this is one area where Watson is actually very far ahead than everybody else is, and that is in the ability for it to do textual analytics because of so it was born and bred for Jeopardy, right? So because it was born and bred for Jeopardy, it was very textual, very conversational. So whenever you have those kind of use cases, it does a little bit better, and they're a little bit further than that. Things like interactive conversation. So think about any call center. I mean, when you make a phone call, like they gave some examples of, like I did an interview with a nuclear scientist from Sandia Labs, and he said, look, I work as a nuclear scientist. A lot of questions we have is, how should this piece of equipment work in this particular condition, in this particular nuclear reactor? And he's like, that, but I don't need to answer those kind of questions. I mean, those are technical support questions that could easily be answered if Watson were taught. And so so Sandia is working with IBM to feed in nuclear reactor data so that places like, Abu Dhabi and other places which have never had nuclear reactors, they don't have people. They don't have nuclear physicists sitting around like we do at Sandia National Labs that could just answer those questions. And so what they're doing is saying, okay, could Watson be taught in these use cases? And of course, the answer is yes. And so we saw a number of those particular use cases, lots of professional services use cases where people are simply just asking research and response questions. So in the medical community, it's really being used at the high end right now. The idea of treatment and finding cures when it's a complex condition that humans find difficult because of the amount of information, not because of the intelligence necessary, but because of the amount of information. But healthcare is missing a grand opportunity to just do support, right? If like a WebMD or any educational site wants to present information about medical technology or medical diagnoses, it could do that in a conversational chatbot-like format. So those are the ones that are happening today. I mean, they're pretty real and are just going to grow. The coolest thing I saw, though, probably was in the space of video analytics, and that was, they showed an example where they took one young lady from IBM, they ruffled her hair and everything, made her look like a criminal, took her picture, and then fed this into the video analytics system. Then they had cameras that were showing how she was walking through the conference area, and there was a little box around her face. It showed her as she was walking through all the different cameras where she was going. So, I talked to some of the IBM healthcare folks and said, this would be great to track patients. If they walk out of the room and they're not supposed to be walking out of the room, it'd be great to track nurses going back and forth to say which patients need the most attention and which don't. So this idea of video analytics and imaging analytics broadly and this video analytics more specifically, what it has shown us is that we don't always have to think about sensors as the way for us to track things. Like in hospitals today, we track assets by putting RFID tags on them. Well, if we had enough cameras around, and the cameras were tracking the assets because they could recognize them, right? Like human beings can see things and we can see, oh, there's an infusion pump sitting there, let me grab it. that can be done. Of course, there are some issues because you can't put cameras inside bathrooms and inside places like patients' rooms and watching what they're doing all the time. But this idea of imaging analytics and finding out things that are going on because of video and images instead of sensors, much like our cars today, self-driving cars today versus the way we thought of them 30 years ago. 30 years ago, we thought we'd have to put sensors everywhere on roads, in signal lights, etc., because that's the only way that computers would know where things are. But now we have such good imaging systems that we just show something to a computer because we've taught it what objects look like. We have edge detection, we have face detection, we have object movement detection. If we teach it enough, that's what we were talking about at a few of these side conversations, is what kind of cool things could we do in hospitals with just image and video analytics that would prevent us from having to go and tag everything in there.
Right. So how about in the radiology space then? Because based on all the descriptions that you've given today, that seems like a primo place where you have a very repeatable process. You would have the obviously an image you're dealing with, and you would have a really capable feedback loop in terms of comparing, as they did with the cancer diagnosis, what was read versus what did IBM read in a lot of past cases. Seems like a good one. Fertile ground for going and doing some training. Is anything happening there?
Definitely. And IBM just bought last year Merge Healthcare, which is one of the largest independent radiology systems that tracks these kind of images and things. So they're on it. So I didn't get to see any specific demos around that, but you're right. It's called imaging diagnostics. So automated imaging diagnostics and imaging decision support system. So IDSS is the broad category there. There is work going on there. But because of the regulated 510K necessary for all of these systems, they take a little bit longer than some of our other systems where they're unregulated in many cases, so you can do them much faster. But they're definitely the guys, at least the guys from IBM, I haven't seen it from other systems, but they're on it. We know that they're serious because they paid a lot of money for Merge Healthcare. And so all those images, once they work out their data use and reciprocal rights agreements and things like that, they'll be able to pour that into Watson. And now where things get really cool and interesting is, so you have treatments and audits from medical records. Now you can tie them to images and labs as well. So you have digital chemistry, you have digital biology, the kinds of things like we were talking about, genomics. Then you have bioinformatics, broadly speaking, through digital biology. But then you've got these imaging capabilities now, which you can tie in. So you know that a person with this kind of cancer and this kind of molecular profile also shows this in their fMRI and this in their x-rays and this in their MRIs. Now all of a sudden you can make learning linkages that were just never possible before. So a lot of cool things are going to happen as soon as both guys like us on the tech side and on the business side start working with doctors. Now imagine a doctor who has been trained in school to never have seen a patient. Those are radiologists, right? They don't see these patients. They look at patients through these images. Now, what if they were teaching Watson and other cognitive systems? These are the patterns that I look for. So you can do anomaly detection and things like that starting first off, but then add through, what if you had thousands of radiologists now pressing the yes, no button, yes, cancer, no cancer, yes, cancer, no cancer on specific things that they find. Right now, our radiology systems aren't training systems. They are reference systems where I look at it, I do report, I write the report, and it goes out. But what if during this process when I was doing it, I was training the computer as to how I'm thinking, and then over time it learns. I think we're in for some pretty good surprises in the future.
That's great. And so speaking of guys like us and using this technology, obviously we've covered the big health systems, the groups with huge amounts of data. You've made it clear that they should be evaluating this technology and getting involved. But there's also these APIs that are available right now. You can go to IBM's site, you can get a key, you can start working against them. Documentation out there, everything. You could probably have something up and running today that could use some of the more basic Watson API offerings. An example was I'm involved with a project where we're conducting surveys and we're using the sentiment analysis in two different ways. One is we're using it to evaluate the questions that we're putting out, because when you're communicating and you're trying to get a piece of information from a large number of people, how are they going to perceive the question? How are they going to feel about the way you ask that question? And sometimes you might want to sometimes you want to make sure that you don't pull an anger response for them, for example. So is somebody going to perceive this as an angry question, or are they going to get angry about the question? And then on the flip side, using that same API to go out and say across thousands of respondents to this survey or to this particular question, what was their overall sentiment, or what were the characteristics of their overall sentiment? So there's things out there like that right now. Obviously that platform, there's like social media analysis that'll come through somebody's Twitter profile and give you some information about them, and a bunch of others that the examples are escaping me right now. Did they get into those types of APIs at all at IBM World of Watson? In either way, have you seen or used any of those out in the wild to date?
Yeah, so lots of their sessions were exactly on this topic, getting developers to come and, while they're sitting there, start using the APIs that are already available. So for example, Bluemix, which is the IBM cloud service, which I've got a number of contacts in, they're hard at work at that. They're trying to at least get the developer experience to where developers don't need to know anything about the machine learning and the cognition part. They know their piece. They put their piece in. Like you made the linkage between sentiment analysis, which is the API, and how it could be used, which is a piece that IBM doesn't know, right? I mean, obviously they have some ideas, but they don't really know how the developers are going to use it. So they've been bringing hordes of developers like us to talk and say, what would you do here? How would you use it? So I was very impressed that they sat there listening to us, right? Say, what would you do here? What would you do there? And as in many cases, I was the one doing the talking. I started to lay out, here's an idea for how you could do this in a hospital. Here's an idea how citizens, like I gave some examples about how today, if you go to a website for citizen-centric services, much like you would go to a website for medical services, you have to do all the work, right? You have to put in the search features. You have to find the page. You have to look on the page and find where the data is. Instead, this data should be poured into a system with a chatbot in the front that says, what would you like to know? So I'm looking for a pediatrician. Okay, here are some pediatricians. Is this what you mean? And so the interactivity will teach you what they really care about. When all you do is present information, and people are clicking around, you have no idea why they're clicking around, why they're there. But if people are asking you questions and you're responding through chatbots or other means, through a conversational user interface, that should be like the first place. Every developer who wants to be employed a year from now or 5 years from now or 10 years from now should be studying chatbots and conversational user interfaces. In the same way that we were talking about mobile apps in 2006 and 2007, 5 years from now, nobody will not be working on conversational user interfaces. That's the first thing to look at. The second one to look at is if there are scenarios where you have data that's in your databases and you have enough data to do even basic learning, it's okay. You don't have to present those to end users. You should start putting a little bit of cognition, use these cognitive toolkits, whether it's Microsoft, IBM, Amazon's, etc., and start to say, what could I teach it? I mean, just start making some linkages and let it generate and tell you, oh, this is interesting. Here's some groups of anomalies. Here's this. And that'll start to teach you about how machine learning works. So very, very quick ways that you can start doing with just conversational user interfaces and using your own data that you have in your customer databases to try it and say, how could I provide better support for my software or my application to my customers?
Gotcha. Very good. And then one last thing on the same topic that I want to touch on as a right now opportunity for startups or for people putting out new products is that IBM's very hungry for you to come and do this, to come and try the APIs. And there are very good programs out there that, at the base level are pretty easy to apply for and get into, where you'll get accesses to to not just the APIs through the websites that you can go hit right now on your own, but to actually use some of the IBM cloud service platforms, and potentially if you can make a strong enough case for them, if you can go and show them that you are driving revenue, or you're plausibly going to be driving revenue off of something that uses their platform, there's a whole next level of things that you can talk with them about, where they will even start to help you by doing some of the marketing and things around the platform too. So definitely something that I think anybody who's working in the space on a product can be thinking about right now, that is accessible to you. And again, hand it back to you on that one, Shahid. Did they talk at all during those cases about those programs and how that works and how people can go about applying for them?
Yeah, I didn't go to those sessions, but I did see the other ones. I went to those sessions so I could speak more authoritatively about them. But these are monetization of APIs, monetization of data. They did have sessions on those. There was actually a very big area in their cognitive workspace, that the big booth area, called data monetization. So I think they're thinking a lot about that. I don't know how sophisticated their thinking is, or anybody's, right? I mean, this is a brand new area, so it's unclear what level of sophistication one could have in such a brand new area. But you're right, that these guys, everybody is giving away these APIs right now because they want you to latch on to them and use them, because then they know that they can monetize it over time. And there's nothing wrong with that. Everybody should be able to get paid for what they're doing. So definitely, I think the point that you made is jump onto Bluemix, jump onto the the Microsoft Cognitive Toolkit, jump onto Google DeepMind. Facebook has theirs. Look at all of these. They each focus on different areas. Watson's is probably a bit more well branded, well planned. So you can see that if a business needs it, IBM will be backing it with services and stuff behind it. It's unclear when you use Microsoft or Facebook or Google that if you were to build your business around it, how much would they help you in your business? They'll help you in the technology because the tech is available. But a lot of what this cognitive work is, it's the professional services, it's the content curation, it's the knowledge building, the expert system. So it's still pretty human centric and human heavy. So if you're going to work on any platform, you want to make sure that not only are they going to help you with using the APIs, which a lot of people will do, but when you pick up the phone and you want to talk to somebody, you want to get them, like you said, a partnership arrangement, get in front of a customer, get a co-branded website or a product out there. That's going to be a little bit harder with all of the other companies in the space. IBM seems to be a little bit further along, at least a year or two ahead of everybody else there.
Awesome. So that really kind of covers everything that I wanted to touch on today. Is there anything you're hoping to get to that we haven't gotten to yet?
No, I think this was great. No, we've hit the hour mark already. So let's finalize for today, and then we'll pick up over the next few weeks about what we chatted about at Health Impact as well, because those have more specific, immediate impacts, especially associated with MACRA, MIPS, and other things that we'll be covering over the next few weeks anyway.
Yeah, absolutely. My apologies. I forgot you mentioned that, and I didn't have it on the radar to squeeze it in before we got to the hour. But that will be a good topic coming up in the coming weeks. Just real quick, upcoming shows this coming Wednesday, which will be November 2nd at our normal time, noon Eastern on Wednesday. We'll have a show around telemedicine and looking at again, the actual successes that we've seen in the field. We've got a couple of great guests coming on to talk about that. James Edwards from Cloudbreak Health and Nick Adkins, who's basically a telemedicine and evangelist. He's all over the web doing this stuff. The guys are a lot of fun. I think it's going to be a great show. The following week, we're going to be going back to MACRA, and we have some experts coming on from Athena Health, which should be able to give us some great insights into what's happening at those small to medium practices. That's a big part of their user base. And now a couple weeks after the final rule coming back to it, I'm really interested to see what are the challenges they're seeing and what are the questions they're getting. And then we'll be coming back around in 3 weeks on November 16th with Novatix, which does a platform around business process management and document management, where you are exchanging information amongst, say, payers and providers and even patients, and they help you with the business processes around handling that, all of the compliance-related, HIPAA-related things that you need to take care of when you're doing that information exchange and the complexities that come with it. So we'll be breaking into that business process management on the 16th. So those are the next three. I think all of them are going to be great, and thank you for joining us today, and we will see you next week.
Bye, all.